Hi, sixth graders. Today we are working in Chapter 1, Lesson 2, and we are on page 19. We are learning about ratios today. The two standards that we will be learning today are ratios and proportional reasoning, standards 1 and 3. So standard 1 says that our goal is that we will understand the concept of a ratio and use ratio language to describe a ratio relationship between two quantities. And the second standard that we're working with today is make tables of equivalent ratios relating quantities with whole number measurements. So understanding ratios and then using tables to help organize ratio relationships. So we will start off with a real-world link. In her dog walking business, Mrs. DeCarbo walks 2 large dogs and 8 small dogs. Compare the number of small dogs to large dogs. Use yellow counters to represent the large dogs. Use red counters to represent the small dogs. So red for the small dogs and yellow counters for the large dogs. And we know she has 2 large dogs, so we'll just use a highlighter to make 2 yellow circles, and then 8 small dogs. And so, because I know I'm going to be looking for proportional relationships, I'm just going to go ahead and let's make that stand out a little bit more because yellow is so hard to see. I'm going to go ahead and group them together. So I have 8 small dogs. I'm going to match up 4 with that one large dog and 4 with this large dog. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And I just kind of group those together visually. Okay, so red counters and yellow counters. In math, when we use the number counters, typically red, when you think of positive and negative, which you will learn in 7th grade, we usually use red for negative and yellow for positive. So when you use those counters, which I don't have any here at home with me, but they have red on one side, yellow on the other, so you can flip them, okay? And then just for life comparison, when a business is said to be in the red, okay, quote unquote in the red, that means they're not making money, they're in the negative, okay? So, but for this purpose today, we're just using red to represent small dogs and yellow to represent large dogs, okay? And then math, it's helpful if we just get into the good habit, and your science teachers will love this, if you get into the good habit of always making a key, and social studies teachers too. So we can say that a yellow counter represents a large dog. And I'm sorry, if you don't have colored pencils or markers at home, you can just put like a Y for yellow and R for red. And then a red circle represents a small dog. And then, so that's our representation with counters in this box. Then we have some questions to answer about the relationships. So question number 1 says 2 plus what equals 8? There are blank more small dogs than large dogs. Okay, well there are 2 large dogs and there are 8 small dogs. So 2 plus 6 will equal 8. So there are 6 more small dogs than there are large dogs. Number 2, 2 times blank equals 8. There are blank times as many small dogs as large dogs. Okay, so 1 times 4 would give me 4. So there are 4 times as many small dogs as there are large dogs. And then in the number sentence here, it would be 2 times 4 equals 8. Number 3, 8 minus blank equals 2. Okay, well 8 minus 6 equals 2. There are 6 fewer large dogs than small dogs. Okay, so 6 fewer large dogs than small dogs. And then here's a really fun mathematical / language arts just a little important tidbit to not really important, but information to know. So when we're looking at fewer versus less, so do you know when you would use which adjective? So they're very similar words, and they mean very similar things. But mathematically, we would want to know that fewer, we would use this for things that can be counted. Okay, like I worked 7 fewer hours than my husband did. Okay, and then less are things that can't be counted. So like you drank less water than I did. I mean, we could quantify it with ounces, but then we would say you drank 3 fewer ounces of water than I did. So less are things that cannot be counted. Okay, so that's just a little grammar and math lesson there. Number 4, 8 divided by blank equals 2. So 8 divided by 4 is 2. And then when we look at our relationship here, the number of large dogs is 1/4. Because it's a fraction there, the number of small dogs. Okay, so there are 1/4 as many large dogs as there are small dogs. Okay, let's turn the page to page 20 and let's look at the paper clips there. Write a ratio in simplest form. There are many different ways to compare amounts or quantities. A ratio is a comparison of 2 quantities by division. A ratio of 2 red paper clips to 6 blue paper clips can be written in 3 different ways. So when we're writing a ratio, we can write it with the word 2, T-O. We can write it with a colon, 2:6, or we can write it as a fraction, 2/6. As with fractions, ratios are often expressed in simplest form. Okay, oh, the marker bled through the paper there, sorry. So example number 1. Write the ratio in simplest form that compares the number of red paper clips to the number of blue paper clips. So here's our entire group, and they made these black rectangles around the groups just to kind of help us to see the simplest form. So it was red to blue, and that's really important that you look at that order, red to blue. So when we make our ratio, it's going to be red to blue, okay? So we want to make sure we keep that order in mind, because order does matter when we're looking at the ratio. So it's red to blue. So in the whole entire group, there are 2 red, 1, 2, 3, 4, 5, 6 blue. Okay, so that ratio is 2 to 6, and an equivalent simplified ratio would be 1 to 3, because 2 divided by 2 would give me 1. 6 divided by 2 would give me 3. My GCF is 2. So I divide by 2 to get the simplified ratio. Okay, so this tells us that for every 1 red paper clip, I'm just going to scroll down a little bit. So for every 1 red paper clip, there are 3 blue paper clips. Okay, let's take a look at got it A. Write the ratio in simplest form that compares the number of suns to the number of moons, then explain its meaning. Okay, so when we look at the diagram here, we have 1, 2, 3, 4 suns. For every 1, 2, 3, 4, 5, 6 moons. Okay, and so 4 suns to every 6 moons, and then they ask us to write the simplest form. So the greatest common factor, which was our last lesson that we learned, greatest common factor of 4 and 6 is 2. So both of those are divisible by 2. So this simplifies to 2/3. So the ratio in simplest form is 2/3, or 2 to 3. I'm just going to scroll this over a little bit. 2 to 3. And then explain what that means. For every 2 suns, there are 3 moons. Okay, so let's go ahead and move on to page 21. Use ratios to compare categorical data. So categorical data is a little bit different than continuous data. So these are numbers, so we can just continue counting 1, 2, 3, 4, 5, 6. Okay, categorical data, if you look at that root word, categorical, if you look at the root word in categorical, the root word is category. So when we can group something into categories, there isn't any overlap. So what would you like? Would you like an apple or a banana or a pear? Those are 3 distinct categories of fruit. Okay, so there is no like blending of those. Okay, we're not having a smoothie, so you're saying what? So you're picking a category. So use ratios to compare categorical data so we can put things that are somewhat related but they're different, and we can compare them using ratios. Each piece of categorical data can only be assigned to one group. Bar diagrams, also known as tape diagrams, and frequency tables. These are frequency tables. Frequency table sounds really intimidating, but it's not. It's just a table that tells how often or how frequently something happens. Okay, peppermint happened. 9 people said peppermint was their favorite. 8 people said cinnamon was their favorite flavor of gum. 3 people said fruit was their favorite flavor of gum, and 1 person said peppermint was their favorite flavor of gum. So when we say frequency table, this is all we're talking about, how frequently something happens. Sometimes if you're going through a large group of data, like we will with statistics later on in the year, you might add a column here in the middle where you can make a tally chart before you get to your total. Okay, we will do that when we get to histograms, so when we group things together. So categorical data, though, is a little different. Categorical data is, it's either A or B or C. There is no overlap. If it's A, it's not B or C. If it's B, it's not A or C. If it's C, it's not A or B. So it has to belong in one of the distinct groups. There is no overlap. Okay, so ratios can be used to compare data that is categorical as well. So example 2. So this is the frequency table with students who name their favorite types of gum. Several students named their favorite flavor of gum. Write the ratio that compares the number who chose fruit to the number of students. So fruit, 3 people chose fruit, and then we want to get the total number of students. So when we add these all up together, okay, we have 21 as our total. So the number of fruit, it's right here as well. So the number of students who chose fruit was 3 over the number of students total is 21. And then when we look at 3 and 21 have a greatest common factor of 3. So we can divide each of those numbers by 3. 3 divided by 3 is 1. 21 divided by 3 is 7. So in simplest form, it's 1 to 7. So this means 1 out of every 7 students said fruit was their favorite flavor of gum. So like maybe Fruit Stripes gum or something like that. So the ratio can be written this way, 1 over 7, 1 to 7. Okay, or it can be written with the word 2, T-O, 1 to 7. Or it can be written with a colon, 1:7, but we pronounce it, when we read it, we say 1 to 7. So 1 out of every 7 students prefers fruit-flavored gum. Monday's yogurt sales are recorded in the table. Write the ratio that compares the sales of strawberry yogurt to the total sales, and then explain the meaning. So strawberry, so these are the different flavors of yogurt and the number of those, each flavor that was sold. So strawberry, there were 8 servings of strawberry sold, and then the total, we add these up, 3 plus 6 plus 7 plus 8. Okay, and so this is 24. So now we want to look at the ratio strawberry to total, and I think it's always a good idea to write this down just like they did in this example, so you, when you're setting up the different ratios, you can remember the top number is always strawberry, the bottom number is always total. So I require you to label what is what. You always want to label your categories when you're working in organizing data. So the number of strawberry items sold was 8 out of 24. So if we look at the greatest common factor of 8 and 24, both of those are divisible by 8. 8 divided by 8 is 1. Oh, this is where we divide. So divide each of these by 8. Okay. 8 divided by 8 is 1. 24 divided by 8 is 3. So 1 out of every 3 yogurts sold was strawberry. Okay, and we can also write that with words if we prefer, 1 to 3, or we could also write it with a colon there, 1 to 3. So what this means is 1 out of every 3 yogurt cups sold was strawberry. So 1 out of every 3 yogurt cups sold was strawberry. Okay, let's look at Got It B. A pet store sold the animals listed in the table in 1 week. Write the ratio of cats to pets sold that week, then explain its meaning. So we're given this very specific order, cats to pets sold. Okay, so we want to add these up. 8 plus 14, or excuse me, 10 plus 14 is 24, plus 8 is 32. So we know there were 32 pets sold total, and we want to make sure that we're labeling cats to pets, and it needs to go in that order. So if I write it as a fraction, the first category mentioned is our numerator. The second category mentioned, which doesn't have to be a total. It's not always going to be a total. It can be one of the other categories. Like you could say cats to dogs, or cats to birds, or cats to total. It can be any of those. So we always go in the specific order. The first thing goes in the numerator. The second thing mentioned after the word to goes in the denominator. So this is very specific. It's cats to pets sold. And that's the total. So we know that there were 8 cats sold and there were 32 pets sold. 8 out of the 32 pets sold were cats. Our greatest common factor of 8 and 32 is 8. Those are both divisible by 8. So 8 divided by 8 would be 1. 32 divided by 8 would be 4. Okay, so this tells us that 1 out of every 4 pets sold was a cat. Okay, so let's write that down, 1 out of 4, and that's our ratio. And then, and you can write that with the word 1 to 4, the word 2, T-O, or you could write it 1:4. Let's write those all down. You only need to write 1 on your homework, but let's make sure that we understand all 3 ways of denoting or writing that. So 1 out of every 4, okay, 1 to 4 is the ratio, or we can say 1:4. And then explain the meaning. 1 out of every 4 pets sold was a cat. So 1 out of every 4 pets sold was a cat. All right, let's go ahead and turn the page to page 22. There's one more example there. Katie wants to divide her 30 flowers into 2 groups so that the ratio is 2 to 3. Okay, so when we know that we're going to have 2 groups and we want a ratio of 2 to 3, we know that altogether, in order to have that 2 to 3, I need to have 5 separate groups. So I can have 2 in one group and 3 in the other group, or 5 different smaller groupings so that I can put them together as 2 to 3. Okay, so this tells us that we're going to have 5 different items. Okay, so I want to know how many, or 5 different groupings. So how many different, how many flowers are going to be each of those 5 groups? Okay, so 30 divided by 5 gives us 6. Okay, so we'll have 2 groups of 6 and 3 groups of 6. Okay, so then we can make this is called a tape diagram. So it's a really nice visual model. Okay, so here's our group of 2, 1, 2, and here's a group of 3, 1, 2, 3. And if we have those 5 groups total, 1, 2, 3, 4, 5 groups total, 30 flowers divided by 5 groups tells us that we're going to have 6 flowers in each group. Okay, and then the way they're arranged is 2 to 3. So there are 5 equal sections, and each section has 6 flowers. And this tells us that there are going to be 12 flowers in one row and 18 flowers in the other row. Excuse me, group. They didn't say rows, they said groups. So 12 flowers in the first group and 18 flowers in the second group, for a total of 30 flowers. And so that is chapter 1, lesson 2, working with ratios to compare numbers. And we did that with frequency tables, we did that with tape diagrams, and we also did that with verbal descriptions. So really nice work with ratios today.